Okay, YouTube, in my next module we're going to be writing complex numbers in what we call trig form, and in order to do so it's often really helpful to represent complex numbers graphically. So that is, let's quickly review what we mean by a complex number in the first place. We say any complex number, we tend to use the letter Z in trig to represent a complex number, but we say it's some number that has a real part A plus some imaginary part B times the imaginary unit I. We say this is our real part and this is our imaginary part, and we're going to see here that we say graphing complex numbers, what we're going to say is that they're actually vectors, okay? So a vector is just an arrow is what we're going to use for now. We can describe it later as a direction and a magnitude, but we say the graph of a complex number, A plus Bi here, we are going to re-express as x plus yi, and we say it is a vector that starts at the origin and goes out to some point xy here. And you notice that I call this point the point xy, and the reason why is because when we graph complex numbers in standard form, let's go ahead and acknowledge a few things. Starting with this, when you graph a complex number in standard form, we refer to the x-axis right here. This is our real axis, okay, and we're going to label this. So the real axis, and we label the y-axis as the imaginary axis. And so essentially, when you graph a complex number in standard form, all we are doing is we're graphing some point xy that corresponds to both the real part and the imaginary part of this number. So for instance, if I said 2 plus 3i, I would say that, if we were expressing this as some x plus yi, we would say that there would be some complex number 2, 3. I don't mean to write equals here. 2, 3 that would represent the number 2 plus 3i. So essentially, we went 2 to the right on our real axis and 3 up on our imaginary axis, and we draw a dot. And we could say that this represents the number 2 plus 3i. So we could see that we could graph every complex number in standard form so long as we know the real part and the imaginary part. And sometimes the real and imaginary parts are 0. So what we're going to do here is we're going to graph each of these complex numbers, 2 plus 4i, negative 2 minus 4i, and 2 minus 4i, all on this grid right here. Remembering that this is our real axis right here and that this is our imaginary axis right here. So when we look at these numbers here, we say that there are some x plus yi form. We say that this first number here is an x of 2 and a y of 4. So what we'll do is we'll go 2 to the right on our real axis, up 1, 2, 3, 4 on our imaginary axis, and we're going to draw a dot right here. Now the important thing is this, that we need to draw in what we call a vector. Remember I said a vector is no more than, right now, is just some arrow, but we're going to go ahead and draw an arrow that connects us back to the origin. We're going to draw an arrow that points right here. But we get this number and we're going to label this as 4 plus 2i. This is the number 4 plus 2i. So the next number we wanted to draw in, or sketch here, is the vector negative 2 minus 4i. And we notice that our x value here is negative 2 and our y value is negative 4. So we're going to go left 2 and down 1, 2, 3, 4. Draw a dot here and say, okay, so now this number right here is this number negative 2, minus 4i. And it's at the point negative 2 comma negative 4. So we say negative 2, negative 4 is our xy pair. And then also this, we say we get some vector here that points from the origin down in this direction. But that's the number negative 2 minus 4i. And then last but not least, 2 minus 4i. So now 2 minus 4i would say I've got a positive 2 for my x, but a negative 4 for my y. So from the origin, we'll go 2 to the right on our real axis. We'll go down 4 on our imaginary axis here to reflect our 2 real and 4 imaginary units here. And we'll draw in our arrow, and our arrow starts at the origin and it goes out to here. So here's our vector here, and we're going to label this. We say this is 2 minus 4i. Okay. So now all of these complex numbers actually have something in common. I hope you notice here when we look at the graph of these. But all of these vectors, you'll notice that when we were playing around with these values here, we had some combination of 2 and 4 essentially, or negative 2 and positive 4, or vice versa, or both negative. But essentially, you notice that all these vectors have the same, length, okay? And we're going to talk about that later, but also the same reference angles. So some of these things that we're playing around with are consequences of this. I do want to note here, complex conjugates. Remember that if we have a complex number a plus bi, then its complex conjugate is the number a minus bi. So essentially, if we had some complex number 2 plus 3i, I would say its conjugate is 2 minus 3i, and the only difference is that we change this middle sign right here. We don't change the sign on the first term. So we say these are conjugates, and what I want you to notice is that these two numbers here, 4 plus 2i and 4 plus 2i, this is not 4 plus 2i, this is 2 plus 4i. Let me fix that here, but 2 plus 4i and 2 minus 4i are conjugates. You notice that they just reflect across the x-axis here. And then complex opposites. Now this is a little bit different. We say given some number a plus bi. its opposite would be the negative of this number. But see, we're taking a negative of all of this. So like if I did negative a plus bi, that'd be the same thing as negative a plus negative bi, or negative a minus bi, which is what we were talking about when we graphed this negative 2 minus 4i. This is actually the opposite of this. And so you see that if it's the opposite here, it just kind of reflected over here. We get this vector over here that has the same length, same reference angle, but different quadrant, okay? So really quickly, it says, what are the numbers that we graphed in example number 1 all have in common? All these vectors have the same length, and they all have the same reference angle, and I think we can leave it at that for now. So the last thing I want to do before we tune out of this video is graph the following complex numbers, and you notice that these are interesting complex numbers. Here we say 1i, negative 1, and negative I, but remember that we could re-express all of these as complex numbers in standard form. So this would be 1 plus no i's. This would be 0 plus 1. We'll call it 1i right here. We'd say that this is 0. No. This would be negative 1 plus 0 i's. And then we would have 0 plus negative 1 I. So in each of these instances, like this first one here, 1, we would say go 1 to the right and up and down none. This would be the number 1 right here. And I say, well, this would be right there. And we could say, okay, so the next one here, 0 plus I. 0 plus I would be straight up 1 unit and then draw an arrow. Negative 1 plus or minus 0i, or just plus 0i. We would say 1 to the left is what that would be. It's kind of hard to see my vector here. And then we say this last one here is 0 minus 1i. So we'd go left and right none on our real axis, but down 1 on our imaginary axis. So all of these vectors right here, these are interesting standard unit vectors, if you want to give them a name. But essentially, we could say anything that is purely real is going to have to fall on the real axis when you graph it. Okay. So we'd say these two numbers here, 1 and negative 1, you could see that those fell either to the right or to the left. And then purely imaginary numbers, just imaginary, you know, the real part is 0. If the real part is 0, it's got to fall purely on the imaginary axis, okay? And this is true of anything that's purely imaginary. It falls on the imaginary axis. So I just write this here. If we write a real number as a complex number in standard form, its graph has to fall on the x-axis. So we say, we call the x-axis the real axis, okay? And then also, if we write a purely imaginary number, the complex number in standard form has to fall on the y-axis, and so we call the y-axis the imaginary axis, and that's just kind of a recap of what we've already said. So that's how you graph complex numbers. We're going to get into how you write them in trig form next.